Hello friends, I'm Sudhir and in this video we're gonna discuss about lasers. What is laser? Light amplification by stimulated emission of radiation is known as laser. Characteristics of laser light: their coherence, possessing high intensity, high directionality, high monochromaticity. Laser light is highly powerful and it is capable of propagating over long distances and it is not easily absorbed by water. Introduction: Laser, light amplification by stimulated emission of radiation. Maser. In 1939, Towner invented maser, that is, microwave amplification by stimulated emission of radiation. Stimulated emission is invented by Einstein in 1917. Ruby crystal laser, a form of laser, is invented by Maiman in California in 1960. Helium neon laser is invented by Ali Jawan in 1961. Absorption. Let E1 and E2 be the ground state energy and excited state energies respectively. Then E2 minus E1 equals to E, that equals to h nu equals to photon energy. Nu is also frequency, so we can denote it with F also. Here, the rate of absorption depends on number of atoms N1 present in E1 and spectral density U of F of radiation. So probability of absorption P12 is directly proportional to number of atoms into energy density. P12 equals to B12 into N1 into U of F. Spontaneous emission E1 and E2 be ground state and excited state energies. System having atoms in excited state goes to downward transition with emitting photons, that is HF equals to E1 minus E2. Emission is random, so if not in same phase becomes incoherent. The transition depends on atoms in excited state N2. Probability, that is P12 of spontaneous, is directly proportional to N2, that equals to A21 into N2, where A21 is the Einstein coefficient for spontaneous emission. Stimulated emission. System having atoms in excited state goes to downward transition by emitting of photons. Here 2HF equals to E1 minus E2, that is after applying photon energy HF. Emission depends on energy density U of F and number of atoms in excited state N2. Probability P12 of stimulated emission is directly proportional to energy density into number of atoms present in excited state, that equals to B21 into N2 into U of F, where B21 equal to Einstein coefficient for stimulated emission. Thus, one photon of energy HF stimulates two photons of energy HF in same phase and directions. So, we get coherent light amplification of radiation by stimulated emission. Relation between Einstein A and B coefficients. Einstein obtained a mathematical expression for the existence of two different kinds of processes. One, spontaneous emission. Two, stimulated emission. Consider all atoms are in the thermal equilibrium at temperature T, radiation of frequency F, and energy density U of F. N1 and N2 are the atoms in E1 and E2 respectively. In equilibrium, absorption rates and emission rates must be same. That is, B12 into N1 of N1 into U of F equals to A21 into N2 plus B21 into N2 into U of F. So, U of F equals to A21 into N2 by B12 into N1 minus B21 into N2. Let's name it 1. U of F equals to A21 by B21 whole divided by B12 into N1 by B21 into N2 minus 1. Let's name it 2. Boltzmann distribution law. N1 equals to N0 into e power minus E1 by kt. N2 equals to N0 into e power minus E2 by kt. Let's name it 3. So N1 by N2 equals to e power E2 minus E1 by kt. Let's name it 4. But E2 minus E1 is HF, that is photon energy. Let's name it 5. So N1 by N2 changes into e power HF by kt. Let's name it 6. U of F equals to A21 by B21 whole divided by B12 by B21 into e power HF by kt minus 1. Let's name it 7. According to Planck's radiation formula, U of F equals to 8 by h into F cube by C cube into 1 by e power hf by kt minus 1. Let's name it, where B12 equals to B21 and A21 by B21 equal to 8 by h into F cube by C cube. Let's name it 9. So, ratio of spontaneous to stimulated emission R equals to N2 into A21 by N2 into B21 into U of F, that is equal to 8 by hf cube by C cube into U of F. Let's name it 10. So, U of F equals to 8 by h into F cube by C cube into R. Let's name it 11. And U of F equals to 8 by h into F cube by C cube into 1 by e power hf by kt minus. So, R equals to e power hf by kt minus 1. Let's name it 13. If hf is very less than kt in thermal equilibrium, then R is very less than 1. When hf is very less than kt, that is stimulated emission, it is valid in microwave region, that is measure. When hf is very greater than kt, it is spontaneous emission, valid in visible region and is incoherent. Types of laser. There are three types of laser: solid laser, that is ruby laser, liquid laser, and gaseous laser, that is helium neon laser and carbon dioxide laser. Ruby laser. To produce laser from solid, ruby crystal is used. Ruby is an aluminium oxide crystal L2O3 in which some of the aluminium atoms have been replaced with chromium plus 3 ions possessing 0.05% by weight. It was the first type of laser invented and was first operated by Maiman in research laboratories on 1960. Chromium gives ruby its characteristic pink or red color by absorbing green and blue light. For a ruby laser, a crystal of ruby is formed into a cylinder. The ruby laser is used as a pulsed laser, producing red light as 6943 angstrom units. Ruby crystal is surrounded by xenon tube as shown in previous diagram. Ruby crystal is fully silvered at one side and partially silvered at the other hand. A strong beam of blue-green light is made to fall upon crystal from xenon tube, and this light is absorbed by crystal. Because of this, many electrons from ground state or normal state are raised to the excited state or higher state, and electron falls from metastable state. During this transition, photon is not emitted, but excess energy of electrons absorbed in the crystal lattice. As electron drops to metastable state, they remain there for some certain time, equivalent to 10 power minus 6 seconds. Thus, the instant blue-green light from the tube increases the number of electrons in metastable state, and then the population inversion can be achieved. If a light of different frequency is allowed to fall on this material, the electrons move back and forth between silver ends of crystal. While moving through, they get stimulated and excited electrons radiate energy. Thus, radiated photon has the same frequency as that of instant photon and is also in same exactly phase. When the intensity of light beam is increased, the same process is repeated. Finally, extremely intensified beam of light energies from the semi-silver side of the crystal is obtained. This way, it is possible to get extremely intensified and coherent beam of light from the crystal. This beam is nothing but the high energetic beam, that is ruby laser beam. Applications of ruby laser. Ruby lasers have declined in use with the discovery of better lasing media. Many non-destructive testing labs use ruby lasers to create holograms of large objects, such as aircraft tires, to look for weakness in the lining. Ruby lasers were used extensively in tattoo and hair removal. Drawbacks of ruby laser. This laser requires high pumping power because the laser transition terminates at ground state, and more than half of ground state atoms must be pumped into higher state to achieve population inversion. The laser output is null gas laser. HEND lasers have many industrial and scientific uses and are often used in laboratory demonstration of optics. HEND laser is an atomic laser which employs a 4-level pumping scheme. The active medium is a mixture of 10 parts of helium to 1 part of neon. Neon atoms are centers and have energy levels suitable for laser transitions, while helium atoms help efficient excitation of neon atoms. The most common wavelength is 6328 angstrom units. These lasers produced powers in the range of 0.5 to 50 megawatts in the red portion of the visible spectrum. They have a long operating life of the order of 50,000 hours. The diagram is a demonstration of helium neon laser. Construction. It consists of a glass discharge tube of about typically 30 centimeters long and 1.5 centimeter in diameter. The type tube is filled with a mixture of helium and neon gases in the ratio of 10:1. Electrodes are provided in the tube to produce a discharge in the gas. They are connected to a high voltage power supply. The tube is hermetically sealed with glass windows oriented at Brewster angles to the tube. The cavity mirrors are arranged externally. Working. When the power is switched on, a high voltage of about 10 kilowatts volts is applied across the gas. It is sufficient to ionize the gas. The electrons and ions are produced in the process of discharge are accelerated towards anode and cathode respectively. The electrons have a smaller mass, they acquire a higher velocity, they transfer the kinetic energy to helium atoms through inelastic collisions. The initial excitation affects only the helium atoms. They are in metastable state and cannot return to the ground state by spontaneous emission. The excited helium atoms can return to the ground state by transforming their energy to neon atoms through collision. This transformation takes place when two colliding atoms have initial energy state. It is called resonant transfer of energy. So, the pumping mechanism of helium neon laser is when the helium atom in the metastable state collides with the neon atom in the ground state. The neon atom is excited and the helium atom drops back to the ground state. The role of helium atom is thus to excite neon atom and cause population inversion. The probability of energy transfer from helium to neon atoms is more as there are 10 atoms of helium per 1 atom of neon in gaseous mixture. Without the Brewster window, the light output is unpolarized. Because of it, laser output is to be linearly polarized. When the excited neon atom passes from metastable state, that is 3s orbital, to lower level 2p orbital, it emits a photon of wavelength 632 nanometers. This photon travels to the gaseous mixture parallel to the axis of tube. It is reflected back and forth by the mirror ends until it stimulates an excited neon atom and causes it to emit a photon of 632 nanometers with stimulating photon. The stimulated transition from 3s level to 2p level is laser transition. Although 6328 angstrom is a standard wavelength of helium neon laser, other visible wavelengths, that is 5430 angstrom units, that is green color, 5940 angstrom units, yellow orange color, and 6120 angstrom units, red orange, can also be produced. Overall gain is very low and it is typically about 0.010 to 0.1%. The laser is simple, practical, and less expensive. The laser beam is highly collimated, coherent, and monochromatic. Applications of helium neon laser. The narrow red beam of helium neon laser is used in supermarkets to read barcodes. The helium neon laser is used in holography in producing the 3D images of objects. Helium neon lasers have many industrial and scientific uses and are often used in laboratory demonstration of optics. Applications of laser. It can be used to predict earthquake. It is used in holography. It is also used in military like LiDAR scanners. It is used to accelerate some chemical reactions. It is used in holography. Laser tools are also used in surgeries. Holography. What is holography? Holography, from Greek is hol plus right, is the science of producing holograms. It is an advanced form of photography that allows an image to be recorded in 3 dimensions, that is length, breadth, and height. Holography is a method of producing a visual 3-dimensional image of an object by means of light wave patterns recorded on a photographic plate. It is known as lensless photography. It produces lifelike images. Dennis Gerber. It is known as lensless photography. It produces lifelike images. Denis Gabor, father of holography and holographic techniques. Later, he received the Nobel Prize in Physics for his inventions in 1971. Hologram. A photograph of an interference pattern which, when suitably illuminated by laser light, produces a three-dimensional image is known as a hologram. Hologram properties. If you look at these holograms from different angles, you see objects from different perspectives, just like you would if you were looking at a real object. It shows divisible property, that is, if you cut one in half, each half contains whole views of the entire holographic image. Working of holography. Laser light, usually helium neon laser, is used. A beam splitter device that uses mirrors and prisms to split laser beam into two beams. Object beam and reference beam are used. Mirrors direct the beam of light to correct locations. Holographic film to record image with very high resolution can be seen through naked eye and image floats in free space. How to create a hologram? A laser beam of coherent light is split into two beams, reference beam and object beam. Reference beam that stays undisturbed and object beam strikes the object and then bounces onto the plate. Working of holography is divided into two phases, recording and reconstruction. Recording of a hologram. When a coherent light beam is incident on a beam splitter, it divides into illumination beam and reference beam, where the illumination beam falls on the object and then reflects to the photographic plate, and the reference beam also gets reflected to the photographic plate by reflecting from the mirror. This is a diagram showing the recording of a hologram. Reconstruction. When a hologram is later illuminated with coherent light of the same frequency that created it, a three-dimensional image of the subject appears. Photography versus holography. Photography, it's a 2D recording process. Ordinary light can be used. It's a lens system and image has a poor resolution. In holography, it's a 3D recording process. Only laser light can be used. It's a lensless system and possessing very high resolution. Applications of holography. It is used in optical computers, biomedical application scanners, and holostores.